All right, let's talk about survival. Because right now, in the digital world, a massive shift is coming. Some people are even calling it a crypto apocalypse, and it threatens to make all of today's secrets readable tomorrow. So the big question is, how do we actually future-proof our data? Let's dive in.
Now, this whole explainer is based on a software security engineering lecture from a real expert in the field, Assistant Professor Engineer Abdul Mahmood. He's an IT and cybersecurity consultant, and he's also the author of the Alpha Peeler crypto tool. And look, that's a huge deal because that tool is officially used in certified ethical hacking labs, and it's even distributed with Dr. William Stalling's famous textbook on cryptography and network security. So yeah, we're in very good hands here.
And he kicks things off with this one idea that really changes everything. He says, don't just migrate to PQC. Build your platform so you can hot swap crypto algorithms. Think about that. The goal isn't just to find the next perfect encryption. The real goal is to build systems that don't really care what the next algorithm is, systems where you can swap them in and out on the fly, kind of like changing a tire while the car is still moving. It's a completely different way of looking at the problem. So, what is this crypto apocalypse we're talking about? I know it sounds super dramatic, right? But it's less about one big single event and more about a new reality that we just have to get ready for. Let's break down what the threat really looks like.
You know, this huge push for what's called post-quantum cryptography, or PQC, these new algorithms that can stand up to quantum computers, it might feel like we're crossing a finish line. But really, it's the starting pistol for a whole new race. Because new vulnerabilities are always going to be found. Quantum computers will get faster, and today's unbreakable code is just tomorrow's broken lock. The only thing we can count on is constant change. Our systems have to be ready for that.
Okay, so if the problem is constant change, then what's the solution? Well, it's a concept called crypto agility. And honestly, the best way to think about it isn't as some fancy new feature, but as an insurance policy for your entire system.
And here's the official definition. Crypto agility is an architectural property. That's the key phrase right there. It means your app's main logic, the stuff that makes it work, is totally separate from the encryption it's using. So when a new algorithm comes out, or worse, an old one gets broken, you can just make the switch without having to spend months rewriting your entire application from the ground up.
And this just lays out the difference perfectly. In a non-agile or brittle system, the algorithm is hard-coded right into the application. Migrating is this huge, painful project. There's no versioning. And trying to run two algorithms at once? Forget about it. It's impossible. But in an agile system, the algorithm is just a setting in a config file. A migration can happen while the system is still running. Every single piece of encrypted data knows exactly how it was encrypted. And supporting multiple algorithms at once isn't a problem, it's an expected core feature. I mean, the difference is just night and day.
And this is the point that really drives it home. This isn't a problem for mathematicians to solve in some lab. This is a challenge for us, for software engineers, for architects, for developers, to solve in our code. It's about how we build things, not just about which fancy equations we decide to use.
Okay, so the theory makes sense, but how do you actually do it? How do you build a system like this? Well, let's get practical and look at the architect's blueprint.
It turns out there are 4 core patterns that make real crypto agility possible. We're going to walk through the first 3, which really are the foundation for everything. Building a modular layer, tagging all your data, and designing for a world where you're running 2 algorithms at once. First up is the modular provider. Just look at this diagram. Your app's logic doesn't talk directly to AES or Kyber or whatever new algorithm comes along. No, it talks to a middleman, a kind of crypto facade. And this facade is the one that decides which provider to call. This means you can add, remove, or change out those providers on the right side all day long without ever having to touch the application logic on the left. It's just a beautiful piece of abstraction. The second pattern is just as important. Every single piece of data you encrypt, your ciphertext, needs to carry its own metadata. It needs to basically have a little tag on it that says, hey, I was encrypted with algorithm number 1, version 2. Why? Well, think about it. 10 years from now, when algorithm number 1 is totally retired, your system is still going to have a vault full of data encrypted that way. This tag is the only way your system will know how to decrypt it. It's like leaving a self-describing map for your data's past.
And that brings us to this idea of a dual algorithm mode. This is where agility gets really, really powerful. A truly agile system needs to be able to decrypt with an old algorithm, while at the same time, it encrypts all the new stuff with the new algorithm. This is the secret to zero downtime migrations. You can roll out a new PQC algorithm, test it in production, and if anything goes wrong, you can safely roll back, all without ever taking your system offline. It's a game changer. So what happens when you don't build this way? Let's look at a few cautionary tales from the real world. Some examples of systems that got completely and totally stuck because they just weren't agile.
And what's wild here is just how widespread this problem is. In the telecom world, it took more than a decade to get rid of a weak cipher in 2G networks because it was baked in so deeply. In banking, you had systems using the ancient DES cipher all the way into the 2020s just because the applications were hard-coded to it. And just think about all the smart devices out there, the IoT stuff, with firmware that can't be updated. They are permanently stuck with whatever crypto they shipped with forever.
And this quote just hits the nail on the head. The problem with those systems wasn't that they picked the wrong algorithm back in the day. The problem was that their architecture was brittle. It was built to last, but it was never built to change. The architecture itself was the real vulnerability.
Okay, so we've seen the problem, we've seen the blueprint for a solution, and we've seen what happens when you get it wrong. Let's wrap up with a clear, actionable plan for how to start building systems that are actually designed to survive all this. Here it is. This is your checklist. Tag every single piece of encrypted data. Use an abstraction layer. Never, ever, ever hard-code your choice of algorithm. Put it in a config file, a database, anywhere but in the code. Plan on keeping your old decryptors around for a while. And always build with this philosophy. Prefer the new algorithm, but be able to tolerate the old one. That's how you get graceful, painless transitions.
And we come right back to this central idea. You're not going to put crypto agility on a marketing slide. Your customers will probably never even see it. But it's the insurance policy that guarantees your product will still be secure, still be working 5, 10, even 20 years from now. It's a pure investment in survival.
Because when it comes down to it, agile systems are the ones that survive. They survive when algorithms get deprecated. They're going to survive the massive post-quantum transition. They can survive emergency patching when a new critical vulnerability is announced. Simply put, they're built to withstand the test of time, because they are built from day one to adapt.
So we'll end with a question take back to your teams. The future is going to bring constant cryptographic change. That is a guarantee. So the only real question left is, are your systems built to survive it, or are they built to die?